Hi everyone. Our lesson today about Newton's laws of motion. Since we studied about forces, types of forces and the effects, we will make an application of balanced and unbalanced forces on Newton's laws of motion. You have already taken this lesson in grade 6, but of course here we are going to develop it in a different way. Is the boy at rest or in motion? Explain. I will wait for you to give your answer, or you pause your video in order to check your understanding. He is at rest and in motion at the same time. He's at rest with respect to the merry-go-round because his position on the merry-go-round is not changing. But his position with respect to the ground is changing. The new question. Why is he holding tight to the iron bar? He wants to fix himself in order not to fall. That's true. But how is it applied to our lesson? It is applied to one of Newton's laws of motion, to the first one. We will see it later. Would he rotate faster or slower if his friend was with him on the merry-go-round? Of course, he would rotate slower, and it is applied to Newton's second law of motion. You will see it later. How can he rotate even faster? Usually, he can put his foot on the ground and he push backward, so he would move forward on the merry-go-round and go faster. This is an application of Newton's third law of motion. As you can see, Newton's laws of motion are applied in many aspects in our life. And it is a very applicable lesson in all fields of your daily life, especially when you are active, you are doing sports, you are riding a car, and everything else. Newton's first law of motion. What would happen if you flick this cardboard that has the glass as a support and a coin placed on the center? Which one will move and which one will not? And why? The cardboard will fly away forward. The coin will drop inside the glass. Reason. The cardboard and the coin were at rest and they tend to remain at rest, but flicking the cardboard caused the cardboard to be set in motion while the coin stayed at rest, so it fell inside the glass. We have another name for Newton's first law of motion. We call it inertia. Usually, inertia is related to the object. All objects have inertia. In other words, all objects have the tendency to stay at rest, to stay in motion unless a force acts on it. But some objects, they have a very big inertia. It means you need a very big force in order to move them. While as other objects, you can move them easily, so they have small inertia. Inertia is the tendency of an object to stay at rest or in motion unless a force acts on them. And that's what we have here. The cardboard and the coin have inertia. A force was applied on the cardboard, so it had the ability to be set in motion. It was at rest, but since a force acts on it, it was set in motion. The coin was at rest and it tends to remain at rest, so it fell into the glass. This is another application of Newton's first law of motion. It talks about the importance of the seat belt, the airbag, and even the headpiece that you have on the seat that supports your head in the back. Both of the driver and the car, while they are in motion, they have the same speed or the same velocity. Both are in motion, let's say at 20 kilometers per hour. They are in motion and they tend to stay in motion, unless a force acts on them, of course. So the car was moving, it hit a wall, so the car stopped, but the man could flow over to the front. How can we apply this to Newton's first law of motion? So the man and the car were moving at the same velocity, 20 kilometers per hour. When the car hit the wall, a force acted on it, so it was in motion and a reason caused it to stop. But the driver was in motion and he tends to stay in motion. That's why he could flow forward. Here comes the importance of the seat belt, the airbag, and even the headpiece that you have on the seat on the back. Now, let's see what is a Newton's first law of motion by definition and by words. An object at rest stays at rest, and an object in motion tends to remain in motion at the same speed and same direction, we mean velocity, unless it experiences an unbalanced force. You remember the forces, and as long as they are balanced, they can be at rest. Whenever an unbalanced force acts on them, they can be set in motion, like for example pulling the rope as you have seen before. Or if you have a ball on the ground and you kick it, it was experiencing balanced forces, then the force of your kick will cause it to move forward. Newton's first law of motion is known by the law of inertia. What is inertia? Inertia is the tendency of an object to resist any change in motion. It means the tendency of an object to stay at rest if it is at rest, to stay in motion if it is in motion, unless a force acts on it. By the way, all objects have inertia. All objects resist the ability to change their condition of moving or at rest unless a force acts on them. How can you explain here Newton's second law of motion? This man is trying to hit a bunt in order to move the ball up higher in the column. What happens if he applied a small force on the hammer? Would it accelerate more or less? It would accelerate less. What if he used a high force? It would accelerate more. So, Newton's second law of motion, it depends on what? It depends on force and the motion it causes it. If the force is smaller, the acceleration will be less. If the force is bigger, the acceleration will be more. There is another rule. What would happen if you want to push two persons on a swing using the same force? You don't want to push one more than the other. Who would accelerate more? The one with the pink t-shirt or the one with the yellow t-shirt? The one to the left can accelerate more. The one to the right can accelerate less. So what is the factor that is determining the acceleration here? Why do we have more acceleration for the person on the swing to the left than the one on the right? It is the mass. The mass is that determines the acceleration. What can we say here? If the mass is less, we can accelerate the person more. If the mass is more, we can accelerate the person less, knowing that we are using the same force. What does Newton's second law of motion state? Newton's second law of motion states that whenever an object is subjected to unbalanced forces, it will be in motion and it will have the ability to accelerate. It means to change velocity within a given time, or to change speed or direction, or both in a given period of time. So in other words, Newton's second law of motion describes the motion and the acceleration of this object. What does it state? Newton's second law of motion states that the acceleration of an object depends on two factors, which are the mass and the force. The mass of the object and the force used on this object in order to cause it to move or to stop or to change direction or whatever. How do we represent it? We represent it by the formula F equals m into A, where F is the force, m is the mass, A is the acceleration. Note that the mass is always expressed in kilograms in this case, the acceleration in meters per second, and the force in newtons. So kilograms times meters per second, it means newtons. We will make applications for that next week. Newton's third law of motion, it is the easiest. It can be summarized by these two words, action and reaction. In other words, the forces come in pairs. The man is exerting an action force downward on the trampoline. The trampoline exerts a reaction force upward on the man. So the forces action and reaction are exerted on different objects. The man on the trampoline, action force. The trampoline on the man, the reaction force. Usually the forces are equal, the action and reaction. Maybe in this example, it's not so clear. But let's say, like when you want to jump on the ground, you exert an action force downward on the ground, which is the support. The support or the ground will exert a reaction force which is equal but opposite direction. It means upward on you, so you can jump for a while. What does Newton's third law of motion state? Newton's third law of motion states that whenever an object exerts an action force on a second object, the second object will exert an equal and opposite force on the first. So action and reaction are equal but opposite in direction. So whenever we talk about Newton's third law of motion, you'd keep these in your mind. Objects exert forces on each other, like the man on the trampoline and the trampoline on the man. Like when you are swimming also, you on the water and the water on you. Forces come in pairs that are equal but opposite. It means you exert, while swimming, you exert an action force with your hand on the water backward. The water will exert a reaction force on you forward, so you move forward. Forces acting in pairs can have an unequal effect, like jumping on trampoline. Usually the elasticity of the trampoline, it helps to exert more force on you to drive you up. Forces can act in multiple pairs. So whenever you jump on the trampoline, don't say that only your feet are touching the trampoline, so they are exerting the force on it. But also the muscles in your feet are exerting the force on your legs as well. That's why playing sports, it exerts lots of energy, because in the same time you are using or you are applying many forces from your body on the object. That's all for today. I hope you will have a great day. An application of the lesson will start next week. Bye bye.